Welcome to the video lecture on quadratic functions. This lecture is going to review some of the basic information, characteristics, and problems that you need to know how to deal with regarding quadratic functions. So let's start off with some important formulas. Now when you talk about quadratic functions, there's typically two different forms that you will see your quadratic function written in. The first type of form is called the vertex form, and this one is very nice if your function comes to you in this notation. What you'll see is this quadratic function sort of in a factored form. You'll see a parentheses x minus h quantity squared plus k. And the reason we like this form is because if you have it in this factored form, it's very obvious where your vertex is. The vertex would just be at positive h comma k. And notice that the h that you use should be the opposite sign of the h that's in the parentheses, and the k should be the same sign as the k that you see in the formula. If this coefficient a is positive, then you'll have a parabola which points up, and therefore your vertex will be a minimum. If your a is negative, then you'll have a parabola that points down, and your vertex will be a maximum. And then we also have something called the axis of symmetry, which is just the vertical line right through the vertex, x equals h, that cuts your parabola right in half. Now another type of form that you'll see that's more common is called the general form. And this is just your ax squared plus bx plus c. Now this one is not as nice because it's not obvious just by looking at the equation where the vertex is. So you have to use something called your vertex formula, and this is something that you do need to have memorized right here. And it says that your vertex can always be located by letting the x coordinate be negative b all over 2a. And then to find the y coordinate of your vertex, just take that x value that you just found and plug it back into your function, and that will tell you y. If a is positive, then you'll have a minimum at this vertex, and again your parabola will point up. If a is negative, your parabola points down, and you'll have a maximum. So please memorize this vertex form, minus b over 2a being the x value of your vertex. You will use that quite often. Now if you're asked to graph a parabola, the pattern for both forms is going to be the same. If the parabola points up, then that means its a would have to be positive or greater than 0. And the pattern would be to plot your vertex, and then you go over 1 up a, over 1 up 3a, and if you wanted additional points, you could go over 1 up 5a. If your parabola points down because a is negative, then you would just go over 1 down a, over 1 down 3 times a, over 1 down 5 times a, etc. Sometimes when you're solving problems, you'll also be asked to find intercepts. The x-intercepts will be found by letting y equal 0, or by letting your function equal to 0, and then you would want to solve that for x. Usually this is a little trickier to do, and some suggestions that I would have would be to try factoring. Sometimes your quadratic might factor, and if that doesn't work, then you might need to try the quadratic formula. And occasionally, there may be no x-intercepts at all. So sometimes there are none. And I'll show you some examples of that in a moment. So x-intercepts, you do have to do a little bit of solving to find them, and it's a little bit of work. The y-intercept should be easy, because to find a y-intercept, you just plug in x equals 0 and you solve for y. And if you're talking about your general form up here, if I let x be 0, then this term goes to 0 and this term goes to 0. So your y-intercept is just going to be that c on the end. So it should be very easy to find your y-intercept. Just plug in 0 for x. Finally, if you're looking at the domain and the range, if your parabola points up or points down, regardless of which case it is, the domain of every quadratic is always all reals. So minus infinity to infinity. Any x can be used. If the parabola points up, then your parabola, if it's got a vertex at h comma k, would have as its range from k all the way up to infinity. If your parabola points down with a vertex at h comma k, then your range would be minus infinity up to a height of k. So it depends on which way your parabola points as to what your range is going to be. So everything on this page is considered information that is review. You should have seen and heard all of this information before, and it is information that I would expect you to have memorized. So we're going to put it into practice and try out some problems. So let's take the function negative x squared minus 4x plus 4. Now the first thing I want to do is take this quadratic, and right now it's in general form. It's that ax squared plus bx plus c, and what I want to do is convert it into vertex form. And remember, vertex form is this a parentheses x minus h squared plus k. It's what we call a factored form. So there's two ways to do this, and I'm going to show you both ways. The first way is probably not the way that I would recommend doing it, but it's possible to do it by completing the square. So here's how you would do that. The first thing you need to do to complete the square is factor out whatever your a is. Factor out this leading coefficient. And when I factor it out, I'm only going to factor it out from the two x terms. So if I pull out a negative, I would be left with a positive x squared and a positive 4x. Now notice how I'm going to do this. I'm going to put a little space, close my parentheses, and this constant, this plus 4 that's on the end, I'm just going to leave it off to the side. So I haven't really changed my function at all. I'm just writing it in a different way. Now, in order to put it into this factored form, hopefully you can realize that I would have to have x plus 2 quantities squared. I'd have to have exactly 1/2 of this middle coefficient, 1/2 of this 4. Because if I were to FOIL this out, I would get the x squared back, and I'd get a 4x in the middle. But what else would I get? Well, I would get a plus 4 on the end, which this does not have in the original problem. These three terms become this quantity squared. But I can't just add in a 4 like this. I have to counterbalance by also subtracting in a 4. And notice I'm doing all this addition and subtraction within the parentheses, within that negative. Okay? So these three terms become this quantity squared. And what I want to do next is somehow combine these two 4's together. But I can't combine this 4 until I distribute this negative across. I'm distributing it to these first three terms by just putting it out front, and if I distribute the negative across to this negative 4, it becomes a plus 4 added to the 4 that we had all the way on the outside to begin with. And so what that means is that these two can now combine, and I get negative quantity x plus 2 squared plus an 8. And all of this is equal to my function notation. So completing the square is a little bit tricky. You need to factor out your a from the two x terms, leave the constant off to the side, take half of your middle coefficient to know what goes inside the parentheses, square that number inside the parentheses to know what you need to add and subtract within side, and then distribute your coefficient across so that you can add your two constants on the end. So it's quite a process. So an alternative to completing the square is to use the vertex formula that we talked about on the previous page. And this formula is used whenever you're given a quadratic equation in general form, so ax squared plus bx plus c. You can't tell what the vertex is just by looking at it, but there's a nice formula that tells you how to compute what that vertex is. So the x value of the vertex has to be minus b over 2a. So what we're going to do is simplify that. The b should be the coefficient of your x term. So here that would be negative 4. So I want minus negative 4 all over 2 times a. And a here is this coefficient of x squared, which would be a negative 1. So I get a minus 4, which is plus 4, over 2 times negative 1 is negative 2, and that reduces to a negative 2. So now that I know what x is, all I have to do to find y is plug it in for these two x values. So y is going to be negative 2 squared using parentheses minus 4 times negative 2 plus a 4. So this negative squares away, but the negative on the outside will stay put. So negative 2 quantity squared becomes a 4, but because of that minus on the outside, it's a minus 4. A negative 4 times a negative 2 is a positive 8, and a plus 4, so that reduces to 8. So my vertex is at negative 2, comma 8. And that actually answers this question down here. So our vertex is at negative 2, comma 8. So you always want to use that vertex formula anytime you need to know what the vertex is, given a quadratic that's in general form to begin with. Now, how does that help us write this in vertex form? Well, once we know what the vertex is, we are going to plug in the h and the k into this generic vertex form using the right signs and using the right a value as well. So if my vertex form in general is f of x equals a parentheses x minus h squared plus k, what should a be? Well, the a in this vertex form is exactly the same a that we used up here, this negative 1. So a is negative 1, or just a negative. And then, remember, we want opposite signs for h. So if my vertex is supposed to be at negative 2, then I need to be seeing an x plus 2 in that parentheses squared. And the k should be the same sign. So if I want a y value of 8, then I need to see a plus 8 on the end. And you can see that that's exactly the same answer that we got from completing the square. So you can do it either way. I tend to like this vertex formula method just because I'm usually having to use the vertex formula to find the vertex anyway, so I just make use of that information instead of having to go through all the work of completing the square. Now, why is it necessary to have the vertex form in the first place? Because that'll answer this next question. If you want to know what kind of transformations are being applied to your function, you need to have it in this factored form. And the reason why is because then you'll be able to see what this negative is doing, what this plus 2 is doing, and what this plus 8 is doing. So a negative on the outside of your function is a vertical reflection over the x-axis. That flips us upside down, which is why this parabola is going to point upside down. The plus 2, because it's inside next to that x, that is a horizontal shift. And remember, horizontal shifts are backwards from what you would expect. So a plus 2 means you probably would think go to the right 2, but we actually are going to go left 2. And then finally the plus 8 on the end, because it's on the outside, that's a vertical shift. And because it's plus, this is going to go up 8. So having it in this vertex form makes it more obvious which way we're shifting, left, right, up, down, and flipping over and stretching and all that kind of stuff. All right, we already found our vertex from our vertex formula, and you could also see that from our vertex form, the opposite h and the same k. Let's go ahead and find our x-intercept next. And the x-intercept is usually tricky to find. You have two options. You could either take your original function and just set it to 0, because an x-intercept is going to occur when the function equals to 0. So you could try to solve this, and chances are usually these don't factor, so on this one you'd probably have to use quadratic formula, which I would expect you to know that formula. Minus b plus or minus square root of b squared minus 4ac all over 2a. Now, just as another option, since we've already done all the work for it, I want to show you that instead of setting the original function equal to 0, we could set this vertex form equal to 0. So it's the same equation, it's just written in a more factored way. And if I set that to 0, sometimes I like to do this instead because it's a little easier to solve. So what I'm going to do to solve this is add this whole quantity squared over to the other side. I'm trying to get the x's on one side and the numbers on the other side. And because it's in this factored form, it's a little easier to solve. We're going to use something called the square root property. So to undo this square, I'm just going to take the square root of both sides. And remember that when you take the square root of both sides, you really are getting two solutions, plus or minus square root of 8. And the square and the square root cancel, giving me that x plus 2. And to finish it off, I could subtract 2 from both sides. So negative 2 plus or minus square root of 8 equals to x. Now technically, square root of 8 isn't a reduced radical because it's root 4 times root 2, which reduces to 2 root 2. So if you wanted to be really careful, you could simplify it. But usually for the purposes of graphing, we need to know what these are as decimals anyway. So you would need to just take your calculator and type in negative 2 plus 2 square root of 2. So that would be 0.828 for the plus case. And then I would go and do negative 2 minus 2 square root of 2 for the minus case. So that would be negative 4.828. So those are my two x-intercepts. So it will require some solving to find those x-intercepts. On the other hand, to find your y-intercept, that should be very easy to do. You're just going to go back up to your original function, and a y-intercept occurs when x is 0. So I'm going to plug in 0 for this x and 0 for this x. So all I'm going to end up with is that constant on the end, that plus 4. So when x is 0, y equals to 4. So that's your y-intercept. Okay? Now, in order to find the domain and the range and find the max or the min, I like to look at a graph to help me do that. So I'm going to go ahead and do my graph first. And what we want to remember here is that we had a vertex at negative 2, 8. And its original equation, just to recopy it so we can have it handy, was negative x squared minus 4x plus 4. Or in its vertex form, that was negative quantity x plus 2 squared plus an 8. So to graph this, the first thing I'm going to need to do is graph that vertex. So negative 2, 8. I'm going to put a dot right up there at the top. And then we need to keep in mind what our a value is, because we have this pattern. And if you remember from earlier on up here, here's our pattern. Depending on what a is, if it's positive, we're going to point up. If it's negative, we're going to point down. And the pattern that you use for graphing is always over 1, down a, in our case, because we want to point down, over 1, down 3 times a. So on my problem, I'm going to go over 1, down a, and in this case, a was just that negative 1, which is why I'm going down. And then over 1, down 3 times 1, or just 3. And we're going to do that on the left and on the right. So this is the pattern that I'm applying based on my vertex. So over 1, down 1, and then over 1, down 3. So here's my graph. Now if you wanted to be a little bit more careful about your graphing, you could make use of those intercepts. Remember that we had a y-intercept at 4, which we happened to graph over, so you can see that that's right at 4. And then we had those x-intercepts at 0.828, so that's just a little less than 1, so my graph looks pretty good there. And then negative 4.8, so that's almost 5. So again, it looks okay here. You could be a little bit more exact in your placement. So using those intercepts just gives you a little bit more detail in your graphing. Now that we have our graph, it should be very easy to answer the rest of these questions. What's the domain of our quadratic? Well, every quadratic always has all real numbers for its domain. Always. The range depends on which way this graph points. So this graph is pointing down. So how low does this graph go? It's shooting all the way down to minus infinity. How high does the graph go? It goes as high as this vertex, which is at a height of 8. And it actually hits it, so use a bracket around that 8. what is the max or the min value? Well, first of all, does it have a max or does it have a min? Because it's pointing down, it has a max. And whenever the question says what's the max value, this word value always implies the y value. So what's the maximum y value that we have here? It would just be this 8, that y coordinate. Okay? All right, so that's one complete problem. We're going to try another one just like it. But this time our function is 6x squared plus 12x minus 5. Again, it's given to us in general form. So if we want to put it in vertex form, you could either complete the square, which is kind of challenging to do, or you can just go ahead and use your vertex formula. So that's the way I'm going to show you here. So let's use our vertex formula, which says that x, the x coordinate of the vertex, has to be minus b all over 2a. So the b in this problem is that 12, and the a in this problem is that 6. So negative 12 divided by 12 equals negative 1. And then to find the y value, we're just going to plug in negative 1 for both of these x's up here. So 6 parentheses negative 1 squared plus 12 parentheses negative 1 minus 5. So that's 6 times 1 is 6 minus 12 minus 5, and that's negative 6 minus 5, or negative 11. So my vertex is at negative 1 for x, negative 11 for y. And I'm going to go ahead and put that down here as well, since we need to know that. Now, once you know your vertex, we can put it into vertex form, which is this a parentheses x minus h squared plus k. Now, what's the a in this function? It's this 6. So we want to maintain that same a, so you still want to keep that 6. And then for my vertex, remember the x value of my vertex was a minus 1, so I need to see an x plus 1 inside the parentheses. And I had a k that was negative 11, so I want to keep that same sign and have a minus 11. So there's my vertex form. Based on that, what are my transformations? Well, the 6 on the outside, because it's on the outside, is a vertical stretch, because it's larger than 1, by a factor of 6. The plus 1 on the inside of the parentheses is a horizontal shift, and because it's plus 1, we actually go left 1. And the minus 11 on the outside is a vertical shift, and it's minus, so we're going to go down 11. Okay, we already got our vertex. Let's find our x-intercepts. And again, your option would be to set this to 0, try to factor it, or try quadratic formula. Or, since we already did all the work here, we can just set our vertex form equal to 0. And usually that's a little quicker to solve. So to solve this, I'm going to add that 11 to the other side. And then I'm going to divide by 6. I want to isolate that quantity squared as much as I possibly can before I take my square root of both sides. So I'm going to get x plus 1 equals, don't forget your plus or minus symbol, square root of 11/6. And then I would want to subtract 1. And I like to put that minus 1 in front of my plus or minus symbol. Now, some instructors wouldn't like this because there's a radical in the denominator. But because we are going to be using these intercepts to graph, we need to know what these decimals are anyway. So I'm not going to bother wasting my time trying to rationalize it, since I just need to know what its decimal is. So I'm going to go to my calculator, and I'm going to type in negative 1 plus the square root of 11 divided by 6. So 0.354 is the positive square root. And then here's a trick that you can do. If you notice in blue here, it says entry. So if I do second enter, it's going to give me back exactly what I just typed in. And if I arrow backwards, I can change that plus to a minus. And that's a quick way to get your other case. So negative 2.354. So those are my two x-intercepts. To find the y-intercept, go back to your original function, plug in 0 for these two x's, and that means my y-intercept is just this constant on the end, so it's just going to be a -5. So y equals -5. Alright, domain, I automatically know that that's all reals, always, always, always. So -infinity to infinity. And before I answer my range or my max or my min, let's do our graph. So remember that our vertex was at -1, -11, and our function was 6x squared plus 12x minus 5, or 6 parentheses x plus 1 squared minus 11. So let's plot our vertex first. So we need -1, -11. I'm going to run out of space here on my grid, but it would be down here. And once I know where my vertex is, you need to look at that A. And in this case, in this problem, that A is 6. And that's going to tell you your pattern to use. Because it's positive, we want to point up. And my pattern is over 1 up A, or in this case 6, over 1 up 3 times A, or 3 times 6 would be 18. So I'm going to run out of space on my graph because this is such a steep graph. But let's try to plot at least a couple side points. So I would go over 1 up 6. And I would do that on the left and the right. And then from here I would go over 1 up 18. So it would be way up here somewhere. And then when you connect these, it's going to be a very, very skinny, narrow parabola. And if you wanted more detail, you could put in those intercepts. We already have the y-intercept at -5. It happened to go right through that point. And then your x's were at 0.354, and at -2, 0.354. So again, mine are sort of in the right position, but you can draw probably a little bit straighter than I can on your paper. So now that we have our graph, what is the range? How low does this graph go? It goes as low as that y coordinate of that vertex, which is -11, and it actually hits it, so use a bracket, and then it shoots up from there up to infinity. So my range would be -11 to infinity. Does this graph have a max or a min? This one has a min. And what is its minimum value, its y value? -11, whatever that y coordinate of that vertex is. Okay, let's try another example, slightly different information that we're going to look for. This time we have -3x squared plus 6x plus 1. Just by looking at that right off the bat, does it have a maximum or a minimum? And how do you know? The reason I know that it has a maximum is because I look at that A, and A here is negative, which means this is a parabola that has to point down, which means it has to have a maximum. So what is the max or the minimum value? That's really asking for how high is that y coordinate. And the only way to figure that out is to know where that vertex actually is. So we're going to have to find the vertex by using that vertex formula. And we have to use that because this parabola is given to us in that general form. So we need to use the formula x equals minus b over 2a. The b in this problem is 6. The a in this problem is -3. So we get -6 over -6, which is +1. That's the x value. So now to find the y value, we're going to plug in 1 for all these x's. So -3 times 1 squared plus 6 times 1 plus 1. So -3 plus 6 plus 1 is 3 plus 1 or 4. So the vertex is at 1, 4. Now make sure you're answering the question. It says find the max or min value, and we know that this has a max, so what is its maximum value? That's the y coordinate or y value. So the answer to this would just be that 4. Now where does this function increase and decrease? Now you can get very, very particular about how you graph this, but I'm just going to do a really rough sketch. We know that this parabola is at has a vertex at 1, 4, so 1, 4, and it had an a value of -3. So according to my pattern, from here I could go over 1, down 3 on either side. And then from there I would go over 1, down 3 times a, or 3 times 3 would be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would put me somewhere down here. So this is a rough sketch of my parabola. Again, not very straight, but use your imagination. And according to this graph then, where does this graph increase and where does it decrease? And this is asking for intervals of increase. So for what x coordinates does the graph rise, and for what x coordinates does it fall? Well, you can see from the graph that it's rising up to this maximum. So what are all these x values? Well, it's all the x's up until x equals 1. So that would be all the way this way up until we hit 1. So that would be the interval -infinity up to 1. And I'm going to use a parentheses right at that 1 because technically at that vertex it's neither increasing nor decreasing. Okay, then what happens? After 1, the graph falls and it keeps falling. So from 1 on this way it decreases. So again, parentheses around the 1 up to infinity. And then finally, what's the axis of symmetry? Remember, the axis of symmetry is the vertical line that cuts your parabola in half. And that means it's going to have to be the vertical line that goes through that vertex. And vertical lines are always x equals a constant. So if it's going to go through this vertex, then it's got to be x equals 1, whatever that x coordinate is. So my axis of symmetry is just x equals 1. Please don't just write 1 down. It needs to be an equation. It needs to have that x equals. All right. To finish off here, we're going to do several different word problems involving quadratic functions. So this first one says, a soft drink vendor at a popular beach analyzes his sales records and finds that if he sells X cans of soda pop in one day, his profit in dollars is given by this function. What is his maximum profit per day, and how many cans must he sell for maximum profit? So a couple of things to note here. We've got a couple variables. We've got x's and we've got this p function. So I like to make a note of what x represents and what this p of x represents because we usually need to refer to that later on. So x is the cans of soda. So it's the number of cans of soda. And what does the p function represent? It's his profit in dollars. So let's make a note of that. And then, what are we trying to find? We're trying to find his maximum profit. Well, in this class, so far anyway, the only way we know how to find maximums is either by using a calculator and using that max command on your calculator, or in this case, because this is a quadratic function, we know how to find maximums from quadratics, because if a quadratic points down, then it will have a maximum. So first thing I want to ask you is this a parabola that points down? Yes, because your a value right here is negative. So this is a parabola that has to point down, and its maximum is going to occur at the vertex. So if you know you have a quadratic function, then you are able to find that maximum always, because we have a formula for how to find a vertex always. And in this case, the vertex formula, this is that one you want to memorize, would be x equals minus b over 2a. So let's use that to find out what the vertex of this parabola should be. The b is this 3, so we want minus 3 all over 2 times a. So 2 times negative 0.001. We use my calculator here, and I want negative 3 divided by, now use parentheses here because you want to divide that negative 3 by both the 2 and the negative 0.001. Close the parentheses. So the x value is 1500. Now to find the y coordinate of your vertex, you're just going to plug in 1500 for both of these x's. So negative 0.001 times 1500 squared plus 3 times 1500 minus 1800. So let's do that. So we need negative 0.001 times, so negative 0.001, 1500 squared plus 3 times 1500 minus 1800. So we get 450. So our vertex is 1500, 450. Now that's not what it's asking for. It doesn't want to know what the coordinates of the vertex are. It wants to know what is the maximum profit per day and how many cans must he sell for maximum profit. Now that really is the vertex, but you need to be a little bit more specific about what each of these coordinates represent and what its units should be. So 1500, that is an x value. And what did x represent? X was the number of cans of soda. So we have to sell 1500 cans of soda for maximum profit. And what is the profit? What is the actual profit in dollars? Well, that's what your P of X is, which is just another way of saying your Y. So this 450 is what our maximum profit will be, and its units would be dollars. So you could write it this way. We need to sell 1500 cans of soda for a maximum profit of $450. So in these max-min problems, assuming that you've got a quadratic, all you have to do is use your vertex formula to identify the x and the y coordinate of your vertex, and then one of these will be your x, and one of these will be your y, and just make sure that you're answering the actual question that was being asked. This one happened to ask for both x and y, but sometimes the question would only want to know what the x is, or sometimes the question just wants to know what the y is. So read the problem carefully. Alright, let's try another example. Now this is a very famous problem. You'll see this kind of math problem over and over again. This one says that a farmer has 2,000 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that encloses the most area? Now, since we're talking about a rectangle, it's a good idea to draw a picture here. So let's just draw a rectangle. And we're trying to find some dimensions, so we don't know either one of these dimensions. So let's just call this x and this y. But what do we know about this rectangular field? We know that we have 2,000 yards of fence to enclose this field. Well, what is that also known as? If you're going or enclosing that whole field, you're going all the way around its perimeter. So 2,000 yards is really our perimeter. And what is the formula for the perimeter of a rectangle? Perimeter of a rectangle is normally 2 lengths plus 2 widths, or in this problem, that would be 2 x's plus 2 y's. And what do we want that perimeter to equal? We want it to be 2,000. So this is one very important restriction on our problem. This is sometimes called a constraint. This is what has to be maintained. We have to have that this perimeter is exactly 2,000 yards. Now, what else are we trying to figure out in this problem? It's asking for what are the dimensions of the rectangle that enclose the most area. So how do you find the area of a rectangle? Well, in general, area of a rectangle is length times width. So in our rectangle that has dimensions x and y, that would be the area, it should be x times y. This is called our objective, because what we want to do here is we want to maximize this. If we're trying to find the most area, then we want to make this area as big as possible, so we want to maximize it. So here's what we're going to do in a problem like this, where you have a constraint and you have an objective. You're going to use the constraint to solve for one of your variables, and then we're going to take that variable and substitute it into our objective to reduce the number of variables involved. So right now here we've got x's and y's, and that's just too much information for us to solve or do anything with. But if we take a look at our constraint, I can easily solve this for y. And you could also solve for x. It doesn't matter which variable you solve for. Usually I just pick whichever looks easiest. And in this case, they're both equally the same. So I'm going to subtract 2x from both sides. And then to finish solving this for y, I'm going to divide every term by 2. So we get y equals 1,000 minus x. Now put a box around that because we will come back to that later. Now that we know the restriction between y and x, this is the relationship that has to exist between these two variables, let's substitute that formula in over here for y. So my objective for my area becomes x, and no longer times y, but instead times 1,000 minus x. And let's go ahead and distribute that x across, so we get 1,000x minus x squared. Now notice, this has a square in it, which means this is a quadratic function, and that's the whole theme of this video lecture today. So because this is quadratic, we can use some information about quadratics and parabolas to help us find where this maximum has to occur. If you want, you could reorganize this and put the x squared term first, just to make it look more like a quadratic in descending order. So this is a parabola because it's an x squared, and it points down because of that negative in front. And if it points down, that means it has a max. And where does the max occur? At the vertex. How do you find a vertex of a parabola? You use minus b over 2a. So all of these steps sort of follow one another. Once you see that you've got a quadratic, then you can locate its vertex by doing x equals minus b over 2a. The b in this problem is this 1,000. The a is the negative 1. So we get negative 1,000 all over negative 2, which equals positive 500. Now if we plug that back in to find our y coordinate, normally we would call this y, but I'm going to have you be a little bit careful here. This isn't really going to be what y is, because this function that we have right here isn't equal to y. It's actually equal to a. So when you take this 500 and you plug it back in for x, you're not finding what y is. You're finding what a is. You're finding what the area actually is in this problem. And that's sometimes tricky to see. So if I plug in 500, I'd get negative 500 squared plus 1,000 times 500. And I'm going to skip the typing into the calculator here, but this comes out to be 250,000. So when we take our x value of 500 and we plug it back into our function up here for x, remember that that's not finding the y value, it's finding what this function represents, which in this case is area. So we just calculated the area, the maximum area of this rectangular field. Now the next question is that what they're asking for? And if you read the question again, it's asking for what are the dimensions of the rectangle. So we don't really even need to find in this particular example what the area is. However, sometimes they will ask for that, so I wanted to show you how to compute that value as well. So let's talk about how to find these dimensions. So the dimensions of our rectangle here are x and y. So do we know either the value of x or the value of y? Yes, we know x. We already calculated that over here. So this is our x value. So we know one dimension already. We know that our x needs to be 500. And what kind of units should that have? Well, since we're talking about 2,000 yards of fencing, then we would want to use the same units. So in this case, our x dimension, our x length right here, should be 500 yards. So that's one of our dimension values. Our other dimension is y. So how do we find y? Well, the quickest and easiest way to find y is to go back to your constraint, which is right here, this place where we put our box around y solved for. So if we take our 500 for x and we substitute it in right here, we'll get that y needs to be 1,000 minus 500, which is going to stay 500. And so our y dimension also needs to be 500 yards. And so in this case, and in this example only, we end up getting not a rectangle but a square. These both of these x and y dimensions end up being the same. So we have a nice square that will maximize our largest area. All right? Okay, for this last example, we have a projectile fired from a cliff 500 feet above the water with a velocity of 400 feet per second. The height h of the projectile above the water is given by this function. X is the time in the air measured in seconds. So let's visualize this situation. We have this cliff, and we're shooting off some object. It's going to go up for a little while, but then eventually gravity is going to pull it back down, where eventually it's going to go and splash into the water. So let's define what our variables are in this function. We've got an x and we've got an h. And the x, they tell us, is the time in the air measured in seconds. So time in seconds. And the height is the h, measured in feet. So what we want to know is, for part A, the maximum height of the projectile. So think about this picture again and notice the way that I drew it. What shape does this have? It looks like an upside down U, which it has to be because this particular function has an x squared in it. So this is a quadratic function, therefore it's a parabola. It points down because this a is negative, and if it points down, then it has to have a maximum. So all we have to do for part A is find the maximum, and the max has to occur at the vertex because that's where it always occurs when it's a parabola. The maximum or the minimum is always at the vertex if you're talking about a parabola. So how do you find the vertex? Well, to find a vertex, you're just going to use that minus b over 2a formula. So x equals minus b over 2a. The b here is 1, and the a is negative 0.002. So this is going to be negative 1 over negative 0.0004. And if we punch that into the calculator, oh, sorry, too many zeros in there. Let's try it again. Negative 1 divided by negative 0.0004. So we get 2,500. And then to find y, we're just going to plug it into our function. For all these x's, we now know that x is 2,500. So this is going to be negative 0.0002 times 2,500 squared plus 2,500 plus 500. And I'll save you the typing into the calculator since my pen isn't being very accurate today. When you plug that in, you get 1,750. Now, to decide which one of these is our answer, let's put some units on these. So remember that x was time in seconds. So this 2500 was an x, so this is seconds. And remember that y here, what I called y, is actually what this function was equal to. So y is synonymous with this function notation h of x. So this 1750 is actually h, and h is height, measured in feet. So this is 1750 feet. So which of these two numbers is the maximum height of the projectile? It's got to be this 1750. So our maximum height is 1750 feet. So that's our solution to part A. Then for part B, we want to know when will the projectile hit the water. So let's look at our picture. You can imagine this object going up into the air and then coming back down, and eventually it's going to splash into the water. So what do we know about its height when it's hitting the water? Since this is the height above the water given by this function, then when the height is 0, that's when it's actually at the water level. So the projectile is going to hit the water when your height is 0. So all we have to do to answer this question is plug in 0 for this h over here. So we're going to get the equation 0 equals negative 0.0002 x squared plus x plus 500. And this is kind of messy because of the decimals, so you're going to want to probably avoid factoring and just jump right in with your quadratic formula, which says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in our problem, our b is 1, so this is going to be negative 1 plus or minus b squared, which is 1, minus 4 times a, times c, all over 2 times a. Now you can do this all at once on your calculator, typing this in, but you have to be really, really careful with your parentheses. So I'm going to do it in pieces, and I'm going to start with the denominator because that one's easy to do. 2 times negative 0.0002 would be negative 0.0004. And under that radical, we're going to get 1. And we have a minus times a minus is a plus. So let's figure out what 4 times 0.0002 times 500 is. It's 0.4. So 1 plus 0.4 would be 1.4 under that radical. And now we're just going to type this into our calculator to get some decimals. So if we do negative 1 plus square root of 1.4, get an answer, and then divide that by negative 0.0004. Notice that we get a negative answer, which we don't want to allow because this solution that we're finding is x, and x is time. So this would say negative 458 seconds, which doesn't make sense in the context of the problem. So we can disregard the plus case. Let's try the minus case. So negative 1 minus square root of 1.4. Get an answer, and then divide that by negative 0.0004, and we get 5458. So this is going to be 5458, and that is, again, your x, and x was measured in seconds. And that's exactly what the question wanted to know. It said when, which is a time, when will the projectile hit the water? So it will take 5,458 seconds to hit the water. Alright, that concludes our lecture on quadratic functions. Make sure that you memorize all of the important formulas and characteristics on the very first page of these notes. Good luck!